All right, folks. By request, I'm going to draw for you a phylogeny of the animal kingdom, including pretty much all of the phyla that I expect you to know a thing or two about. Now, there's going to be a lot of polytomy in this because there's a lot of unresolved issues with the animal family tree. So I'll try to point those out as I go along. So for a very long time, it has been thought that there's one group of animals that are just super weird and super different from all the rest of the animals. And that group is the sponges, the phylum Porifera. In fact, the sponges have been put in their own subkingdom called Parazoa, which means on the side of animals, because they've got a lot of weird things going on, the sponges do. They don't have planes of symmetry. They don't have more than a cellular level of organization. You could take a sponge, you could run it across a cheese grater or otherwise sort of disarticulate it, and it would reassemble itself. That's a very weird thing for an animal to do, and the rest of us animals don't really have that kind of superpower. So, sponges, they are different. We've got 3 classes of sponges, which I'll just draw this as a polytomy because I don't exactly know how these go. 3 classes of the phylum Porifera. We've got the Hexactinellida, which has those 6-rayed siliceous spicules. We've got Calcarea, which has calcium carbonate spicules. And then there's the big one, which is the Demospongiae, where pretty much anything goes in the Demospongiae. So there's some controversy about who comes next in here. So there's some thought that I should have put the Ctenophora, the comb jellies, as ancestral to all the rest of the animals, including the Parazoa. This is a very controversial take. So I'm just going to put the ctenophores up here. And for the moment, I'm just going to kind of indicate that we don't really know where they belong. So I'm just going to write down the words that mean that. Incerticetus means kind of like, I'm not exactly sure what's going on with those ctenophores. But one thing that we do know is that they are not, they don't form a clade with the Cnidaria. The Cnidaria are their own thing. Cnidaria are radially symmetrical animals. They're kind of strange because they're diploblastic, as are ctenophores. And they include 4 classes you should know: Hydrozoa and Scyphozoa. We drew the life cycle of a moon jelly, which is a Scyphozoan. Cubozoa, which includes box jellies, and Anthozoa, which means flower animal, but this is sea anemones and corals are Anthozoan cnidarians. Okay, so then we get into a clade we call the Bilateria. And within the Bilateria, we kind of have 2 paths here. We've got the Deuterostomia, deuterostomes, which includes, for our purposes, we're just going to include 2 phyla here. There's a 3rd phylum, but I'm not going to talk about that. We're just going to leave that where it is right now. The Echinodermata is one that we need to know about. Those include starfishes and sea urchins and sea cucumbers and a number of other things. And the Chordata, which includes all of the vertebrates, every fish, lizard, turtle, mammal, dinosaur, bird, frog, etc., as well as a couple of other subphyla that we'll learn about in our last unit. Then we get into the Protostomia. Protostomes, the fate of the blastopore in embryonic development is that blastopore becomes the mouth. And for these animals, the vast majority of them, the blastopore starts to poke in during gastrulation. It forms a blind cul-de-sac called the archenteron, and then eventually that pokes all the way through and you get a complete gut with a mouth and an anus. In the protostomes, the blastopore becomes the mouth, and the thing that pokes through the other end is the anus. In the deuterostomia, the opposite is true. So first the mouth, or second the mouth, is what protostomia and deuterostomia mean, respectively. Okay, so I'm going to try and give myself a good amount of room here to draw in the ecdysozoa, which are the molting protostomes, and the lophotrochozoa, which are the non-molting protostomes. So non-molting seems like that would be when we have a group of animals or a group of any organism based on something that they lack, that's typically going to be a synapomorphy. Molting was a new thing. So most groups that are united by something they lack are going to be grades. But as it turns out, the Lophotrochozoa do represent a clade rather than a grade. So Ken Holanich, who first coined this term Lophotrochozoa, was like, well, what do they have in common? What synapomorphies do they have that support them being a clade? And he reasoned, after thinking long and hard about it, that Lophotrochozoans either have a lophophore, which is that U-shaped feeding structure that we drew the other day, or they have a trochophore larva. Those are their synapomorphies. Okay, so within the ecdysozoa, it's not really clear, to me anyway, what the how these all diverge from each other. So we've got the nematoda, roundworms that have a cuticle that they periodically shed throughout their lives. Another related but not the same phylum group of worms called the nematomorpha. These are the horsehair worms and the Gordian worms. And then we get into our largest phylum of all, the Arthropoda. And within the Arthropoda, we've got 2 subphyla. We've got the Chelicerata, which includes 3 classes, and we've got the Mandibulata, which includes 4 classes. I'm going to try and squeeze everybody in here. Okay, so within the Chelicerata, among our extant classes, still living, we've got Merostomata, horseshoe crabs, we've got Pycnogonida, the sea spiders, and we've got Arachnida, the arachnids, which includes spiders, daddy longlegs, scorpions, ticks, mites, and lots of other things. And then within our Mandibulata, we've got Chilopoda, which are centipedes. We've got Diplopoda, which are millipedes, Diplopoda. We've got crustaceans in the Crustacea, and we've got Hexapoda, which are, for the most part, the insects. Okay, so that's a little bit different from the way I talked about it in the previous lecture video with the Uniramia being the centipedes, millipedes, and insects. The Uniramia is now considered to be a grade and not a clade. So, yep. I'm not gonna ask you about the Uniramia because they're not really considered to be a thing anymore. Okay, within the Lophotrochozoa, we've got the rest of all of the animals, and it turns out this also includes, we used to think the Platyhelminthes were their own thing. They were acoelomates, and they were kind of outside of this Lophotrocha ecdysozoa divide, but now we know that they are in there. We've got 3 classes of Platyhelminthes. Turbellaria, like the planarian that we drew, cestodes, cestoda, which are the tapeworms, and trematoda, which are the liver flukes. Again, I'm drawing this all as a big polytomy. We've got the Annelida, which includes what I'm calling 3 classes you should know: polychaetes, oligochaetes, and leeches. So Polychaeta, Oligochaeta, and Hierudinia. Although evidence has come out that suggests that oligochaetes are derived from within the Polychaeta. Don't worry about that. Another major phylum of invertebrates are the mollusca. There are 4 major classes you need to know about and 4 minor ones you don't need to know at all. So this would be Polyplacophora, which might be a new one for you. Gastropoda, snails, slugs, nudibranchs, some other things, whelks. We've got bivalvia, bivalvia includes clams, oysters, mussels, scallops, and then cephalopoda, headfoot. So that includes octopodes, squids, cuttlefish, chambered nautiluses, and the like. We also have in the Lophotrochozoa our 3 lophophorate phyla, which are the Phoronida, Ectoprocta, and Brachiopoda. I think I read somewhere that one of these phyla is no longer considered part of this clade, but for our purposes, let's say that they are for now. And then we've got a few kind of minor phyla of Lophotrochozoa, including things like the rotifers, Rotifera, Gastrotrix, Gastrotricha, Nemertea, which we drew a picture of. It used to be thought that Nemerteans were completely acoelomate, but it turns out they have just a very reduced coelom. And am I missing anybody? Nope, I guess that's it. I guess that's it for the ones that we need to know. So now this phylogeny includes all of the phyla that I've talked about. either in lecture videos or in class, and this will hopefully help you to arrange them. Should I ask you, if X and Y are related, A and B, what is C? Those types of questions that I want to ask. All right.